You ever just feel like you're drowning in information, overwhelmed by it all? Well, today we're going to learn the secret language of data. We're talking about the absolute basic vocabulary that helps turn all that noise into something that actually makes sense. So let's dive right in. I mean, think about it. The world is just full of random, jumbled information. From a busy street to the stock market, it can all feel like pure chaos. So the big question is, how do we find patterns? How do we find any meaning inside all of that noise? The answer, it turns out, is pretty simple. We use data. And to make this crystal clear, we're going to use one simple analogy for this entire explainer. We're going to organize a school classroom. Just think of this class as our own little miniature world. By the end, you'll see how the exact same ideas we use here can be applied to, well, almost anything. Okay, first things first. Before we can organize anything, we need our raw material, right? In our classroom, that's the students. In the world of statistics, we just call that raw material data. And you know what? It's really that simple. Data isn't some scary, abstract thing. It's just a collection of information. Whether we're talking about numbers or descriptions or measurements, any observation that you can record is data. So let's bring it back to our classroom. In there, every little detail is a piece of data. The fact that a student's shirt is blue, that's a piece of data. Their height of, say, 170 centimeters, yep, that's data too. Each student is like a little treasure trove of these facts and figures. All right, so we've got our raw data, a room full of students with different heights, different shirt colors, you name it. What's our first job? Our first job is just to describe what we're seeing in a simple, understandable way. And that job actually has a name. It's called Descriptive Statistics. We're not trying to make big predictions or find hidden causes just yet. Nope. We are simply painting a clear picture of the data that's right in front of us. Think of it like you're writing a quick summary of the class for the school principal. For our class, this might mean, calculating the average height to get a feel for how tall the students are overall. Or we could whip up a quick bar chart to see which t-shirt color is the most popular. We're just describing the scene. That's it. Now, to really organize our class properly, we've got to realize that not all data is created equal. You can't treat a student's name the same way you treat their height. So let's break down the different types of data we're working with here. First up, we have categorical data. The best way to think about this is as labels or groups that you can sort things into. And here's the crucial part. You can't really do math with them. You can't add blue plus red. You can only count how many things fall into each category. In our classroom, this is super intuitive, right? We can group students by their t-shirt color, maybe their favorite subject, or which homeroom teacher they have. These are all just categories, simple labels that help us create some order out of the chaos. Okay, so we've handled the labels. Let's move on to the numbers. But here's the thing, it's not quite that simple. Turns out, not all numbers are the same. There's a really, really important distinction we need to make. First, we have what's called discrete data. The key word to remember here, the only thing you need to remember, is counting. This is data that can only be specific, separate values. Think about it. You can have 1, 2, or 3 siblings, but you can't have 2.5 siblings. We're counting distinct, whole things. The other type of numerical data is continuous data, and for this one, the key word is measuring. This is data that can be broken down into smaller and smaller and smaller units. And this distinction is so important because it lets us ask different kinds of questions, like what's the exact average height, not just how many students are in the room. So let's bring this right back to our classroom to make it super clear. The number of siblings a student has, that's discrete. You count them. But a student's exact height is continuous. You measure it. It could be 170 centimeters, sure, but it could also be 170.1 or even 170.15 centimeters. You see the difference? One exists on a smooth, continuous spectrum. So we know how to classify our data by what type it is. But there's one more important layer we got to think about. When was the data actually collected? The best way to think about this next concept is with just one single word: snapshot. Imagine you're taking one photograph of the entire class at one specific moment. In the world of statistics, this is called cross-sectional data. We're looking at a whole bunch of different subjects, all of our students, but only at one single fixed point in time. It's not a movie showing how they change over a whole year. It's just that one photograph of the class on a Tuesday afternoon. And this idea applies way beyond the classroom. A perfect real-world example is looking at the stock prices for all 500 companies in the S&P 500 at the exact moment the market closes today. That right there, that's a cross-sectional snapshot of the entire market. Okay, we've learned about our raw material, how to describe it, and all the different data types. So how do we put all this information together into something we can actually use? Well, let's build our final class roster. We use something called a data table, which, let's be honest, you probably know as a spreadsheet. And it's the standard for a reason. It is incredibly clear. Each row is a subject, so one of our students, and each column is a variable, which is just a fancy word for a characteristic we're measuring. And here it is, our classroom, perfectly organized. Just take a look. Each row is a different student, right? And each column is one of those variables we've been talking about. Height, that's our continuous data. T-shirt color is our categorical data, and number of siblings, that's our discrete data. See? It all comes together in one clean, easy-to-read table. So if there's one thing to take away from all this, it's that data isn't something to be afraid of. It's not just a bunch of random numbers. When we apply these basic ideas, we transform that chaos into clarity. We're really just telling an organized story about what we're seeing. So we've done it. We've taken a jumbled classroom and we've created an organized roster. The foundation has been laid. And that leaves us with the most exciting question of all. Now that you actually know how to organize and read the data, what patterns are you going to find? What story is it going to tell? The real journey? Well, that's just beginning.